8. Then this become an array or a single row with 3, 4, 5, 8. So if I put this, okay, let me give this name as G equal to 3, 4, 5, 8. Now n, suppose we give say 0 to 3, n equal to, you can give this syntax, this is n equal to 0 colon 3, means n takes value from 0 to 3 with an increment of 3, sorry, with an increment of 1. So it will take 0, 1, 2 and 3. So these are the values 0, 1, 2 and 3. So n is another array. If you give n equal to 0 colon 3, you get n as an array which contains 0, 1, 2, 3. Now suppose, so G is 3, 4, 5, 8. So if you give 3, 4, 5, 8, suppose you give G of 0, or suppose you give the problem with our syntax, by G equal to 3, 4, 5, 8, we mean G0 is 3 and G1 is 4, G2 is 5 and G3 is 8. But MATLAB, it doesn't take 0 as the index. So its index start with 1. So G of, basically 3 will be G of 1. In the G equal to 3, 4, 5, 8, G will be, G of 1 will be 3 instead of G of 0 that we consider as 3. And we consider G of 1 as 4, but MATLAB consider it as G of 2. Similarly, 5 is G of 3 and 8 is G of 4. So if you want to get 3, you have to give G of 1. So if I put G of 1, you get 3. G of 2 will be 4 because G is 3, 4, 5, 8. So if I give G of, say, we have given n equal to 0 colon 3, that is n takes 0, 1, 2, 3. So instead, if I give G of n plus 1, you'll get G of 1, G of 2, G of 3, and G of 4. That means you'll get 3, 4, 5, 8. That is the complete G. 3, 4, 5, 8. This is same as G. Okay. Now let us see how we can do some shifting, that circular shifting or circular time reversal using this MATLAB. I have shared material to you, and the questions for the experiments also that you need to do has also been shared. So I'll give you basic understanding of how to do that. So you take, okay, so you have G as 3, 4, 5, 8. So suppose you want to shift this by a circular shifting of 1. So you know that if you shift this by 1 to right in a circular way, instead of 3, 4, 5, 8, you will get 8, 3, 4, 5. Instead of 3, 4, 5, 8, you will get 8, 3, 4, 5. So to obtain that, what you have to give is, you know that n is 0 colon 3, which is 0, 1, 2, 3. So if you give G of n plus 1, you get 3, 4, 5, 8. Suppose you give G of, say, suppose you shift this. How will you shift this? Instead of n having value 0, 1, 2, 3, you want to shift it, means you want to get the value of 3 at 0. Instead of the 1, you want 0, 2, 0, like that. So let us take n again. So n is 0, 1, 2, 3. Suppose you take mode of n. I hope you know what is mode of n. Okay, I'll give another number, say q equal to 0 colon say 20. That means q takes the value 0, 1, 2, 3, etc. to 20. Now if I give mode of q comma 4, what do you expect to get? These values will be taken, it will be divided by 4 and the remainder will be taken. So if you have 0, 1, 2, 3, if you divide it by 4, the remainder after division will be 0, 1, 2, 3, etc. But if you take 4, if you divide 4 by 4, the remainder will be 0. So mode 4 comma 4 will be 0. So this similarly, if you take mode 5 comma 4, if you divide by 4 and consider the remainder will be 1. So this whole q, this array q is going to become 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 like that. So let us see what happens. Mode q comma 4. You can see that it is 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3 because we have taken mode q comma 4. Okay, now suppose you take mode q comma 5, what do you expect? Can one of you unmute and tell?
0, 1, 2, 3, 4, 0. 1, 2, 3, 4, 0.
Very good, very good. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 like that. So let us see. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 like that. Okay. Now the n 0, 1, 2, 3 n, you know, n is 0, 1, 2, 3. This you want to make a circular shifting to the g. G is basically 3, 4, 5, 8. Let us consider that its time index is n, which is 0, 1, 2, 3. To make a circular shift of 1 to the right, you have to give this as g of n minus 1. Suppose you give g of n minus 1 comma 4. This 4 means you are taking with a mode 4. So let us see what this is. N is taking the value. There is one error. Index in position 1 is invalid because g n minus 1 means that n is taking 0 value. So it shouldn't have 0 value. Okay, so let us take n plus 1. Okay. Let us take g of n minus. Let us take another variable, say k equal to mode n minus 1 by 4. K equal to mode of n minus 1 by 1 comma 4. What does this mean? You have n, which is 0, 1, 2, 3. If you take n minus 1, this is going to be n minus 1 is going to be, if you have 0, 1, 2, 3, n minus 1 comma 4 is going to be 0 is going to be minus 1. So minus 1 comma 4 will be 3, which is this. Similarly, if you have n equal to 1, mode 0 comma 4 is mode 0. So basically 0, 1, 2, 3, which is n become n, which is 0, 1, 2, 3 become 3, 0, 1, 2. Okay. So this is basically a shifting in the time index. Now if you give this 0 is not allowed. So for MATLAB 0, index 0 should be replaced with 1. So we'll give g of k plus 1. G of k plus 1. G of k plus 1. So what happened? It become 8, 3, 4, 5. What is g basically? G is 3, 4, 5, 8. while GK plus 1 is 8345. So what have happened? What has happened here? The G, which is 3458, is circularly shifted by 1 to right, and hence 8 came from the last position to first position, and now it become 8345. So now you have 8345, which is the right circularly shifted version by 1, by a factor of 1. So if you want a shift of 2, you can give G of k plus 2. Sorry, G of k plus, instead of G of k plus 2, you have to give 1, 2, 3, 4. Okay, first you have to do the shifting. Then, so you take k equal to, k G of k plus 1. Let us take some other variable, say L equal to mod n minus 2 comma 4. L equal to n minus 2 comma 4, which is of 4. Mod of this. So if you take L equal to mod n minus 2 comma 4, this is a shifting of the time index n by a factor of 2. So if you have taken mod, means the shifting will happen in circular way. So let us take L. So 2, 3, 0, 1 instead of n equal to 0, 1, 2, 3. Now you have the 2 shifted version. That is, it starts from 2. So 2, 3, 0, 1. So now if you take G of L, you take G of L, is it L? Sorry, G of L plus 1, because again you have, if the index 0 come, MATLAB will consider it as an error. So G of L plus 1 is 2 shifted version of your G. So you take G. G is 3458. If you shift it by a factor of 2 to the right, you'll get the 8 will come to this side, then 5. So 5 will be at the beginning, 5, 8, 3, 4, which is GL plus 1. Okay, so this is how you do circular shifting. And for finding circular convolution or finding DFT using circular convolution and all, you require circular time reversal also. How do you do circular time reversal? You have n is 0, 1, 2, 3. So you take, say, another variable, say u. Suppose you take a variable u and you give as minus n. U is minus n. That is, you are doing time reversal, minus n, comma, and mod is with respect to 4, because you have 4 numbers. Your frame is of size 4. So u equal to minus n comma 4. Okay, this is sorry. You have to give mod u equal to mod of minus n comma 4. So you get 0, 3, 2, 1. What is actual n? N is 0, 1, 2, 3. So you can see that here itself the circular shifting has happened. So what you can see is 0, 1, 2, 3 becomes 0, 3, 1, 2. Now if you give G of say G of, or you give another variable, say z equal to okay, you already have u, so you can give G of u plus 1. So if you give G of u plus 1, you are getting 3854. Now what is your G? G is 3458. 3458. If you do circular convolution, you consider it as a circular circular time reversal, it becomes 3854. So this way you can easily find or easily do the circular time reversal, circular shifting, etc. using MATLAB codes. And with this, you should be able to do circular convolution as well as DFT, etc. Um, so I have posted one question. I think that question is DFT. So in that, I'll add one more question in which we'll be doing circular convolution, which is based on this small um, coding. Okay, so we'll do a circular convolution, then we'll find DFT. All these we have inbuilt codes in MATLAB. You can use those inbuilt codes also to verify this, but you have to write the write your own code from scratch. Okay. Um, yeah. So I hope this much is enough. Do you have any doubt? Mm, do you have any doubt? Is the concept clear to all of you? If you can't install MATLAB in your system, you can use this kind of online MATLAB, which you can access if you have a GCTCR email ID, or you can very well install MATLAB or Scilab in your laptop and do it there. So you can do in any way in which are comfortable manner. Scilab, Octave, all these are powerful open softwares. I recommend these than MATLAB, but you can very well use MATLAB also because we have a licensed version in our institution. You can make use of that. Um, so I think this is what I want to convey for today. You can make use of these materials. I'll give this recorded version, the link to this in Moodle, and you can. I have uploaded one question. Along with that, I'll upload one more question of on circular convolution. You can use. You can do it and submit as in the Moodle itself. Okay. So if you have any clarifications or doubts, you can ask now. I'm stopping the recording now.